Hello my friends, my name is Marcos Sarris. I am CEO of Hyperledger, a company that is specialized on blockchain development. Today we're going to demonstrate the creation of a token in a Hyperledger Fabric network using the UTXO concept. UTXO stands for Unspent Transaction Output. Especially on cryptocurrency networks, whenever a transaction will happen, it's necessary to provide some inputs when you want to send some token or some cryptocurrency from one to another. And this transaction will return some outputs. UTXO represents the unspent output of a previous transaction. And it can be used as an input for a new transaction. We can think of the UTXOs as financial changes. Whenever we send some token or some crypto coin from me to other, this transaction can return some changes that are the UTXO. And we can use these changes as the inputs for a new transaction to come. Let's dive in this example right here, where Tom sends 2 bitcoins to Alice. Initially, Tom has an asset with 5 bitcoins, and then signs a transaction that actually sends 2 bitcoins to Alice. The result of this process will be that Alice will have an asset with 2 bitcoins. The 5 bitcoin asset of Tom will be burned, and he will receive a 3 bitcoin asset that will actually be the UTXO, the Unspent Transaction Output. In this demonstration, we will deploy a Hyperledger Fabric network with one channel, and within this channel we will deploy one chaincode using GoLedger 62's library. This chaincode will provide us some methods for wallet creation, token minting, and token transfer. We will have only 2 assets in this chaincode. The first one is the wallet. The wallet is pretty much simple. It's basically one ID, and its public key we will use RSA key pair for this demonstration, and the private key will be used to sign the token transactions. And the other asset is the token that will have the following properties: the text ID of the transaction that created this token, the reference for the wallet, the amount, and a Boolean value if this token has already been used or it has been burned. And then we will have the token minting for creating this token connected to a wallet, and then this transfer among wallets, the token transfer among wallets, and of course the usage using the concept of UTXO. The network will be pretty much simple. We basically will imagine one organization that will provide the wallets. Imagine some kind of ID department that will create. Basically, I will create in this demonstration 2 wallets, one for Marcos and other for Rafael. And the other 2 organizations will think of 2 banks that will mint and transfer tokens among wallets. First, let's take a look on the chaincode that we will deploy on the Hyperledger Fabric network. We call it GoTokenCC, and as I told you, it uses GoLedger 62's library, and it has 2 assets. The first one is the wallet. It's pretty much simple. One ID, that's basically a string for identification, and the public key, both are strings. And the other asset, it's the token itself that basically uses the TX ID, the transaction ID of the creation of this asset as a property, as a part of the key, of the composite key. And other than that, uses also the reference to the wallet as also a part of the composite key, and also the quantity, the quantity of the token that is also part of the composite key. And the last, the other property, it's a Boolean property that says if the token has been burned or not. And I added a last property at the end, basically for didactical purpose, that shows all the spent tokens, that has all the UTXOs that had been used to create another token. This chain code has some methods that I will show the most important ones. The first one is the creation, the ones that creates a new wallet, basically receive the two properties of the wallet, the ID and the public key. It receives as string arguments, and then provides a crypto checking, a verification, using some crypto methods that we, for RSA cryptographic methods, to check if the public key is correct. It's really an RSA public key. And after that, if everything goes right, it basically saves a new wallet in the Hyperledger Fabric network using the GoLedger 62's method put new. The other method is to issue a new token, to mint a new token, but basically receive the information of the quantity of the token, and that in the wallet it is supposed to be minted. So after that, basically we create a new asset and saves in the Hyperledger Fabric network. It is as simple as that. After that, we do have the transfer method for transferring tokens among wallets. And basically we have to receive the orange of the token, the wallet that's these tokens is registered, the destination, that's the tokens are going to be transferred, the quantity, and a signature, a cryptographic signature using the key pair that was registered for each wallet. So basically we will ask for a signature for this transaction to happen. And after receiving all these arguments for this method, we will check again the public key, and then we will create a method to be signed. Basically the message will be kind of a JSON, so we will ask for a sign of this string right here that will be from the ID of the origin wallet and to the destination, the quantity of the token of the transfer, and then we will verify the signature. We will use the cryptographic methods to verify if the sign is correct, and if everything goes right, then we will continue to the transfer. And first we will ask for the tokens from the wallet. Imagine that this transaction we will not use maybe you will not use only one token. It may use several tokens as this concept of the UTXO transfer. And after that, check if it has the necessary balance to proceed with this transfer. And then we will, all the tokens that will be used as this input for this transaction will be registered as burned, as spent, so it will not be used again. And after that, we will change the last token and create we will create a new token that will be transferred to the destination wallet. One last method I'd like to show is the one that returns the balance of each wallet. So basically, this method receives a wallet and then verifies all the tokens from this wallet that had not been spent, that has not been burned, and then returns out the balance of all this, makes a quick query in the Hyperledger Fabric network to check all the tokens that had not been spent, and after that basically shows sums all the quantities of these tokens and returns this value as the balance. One last interesting thing I'd like to show in this chain code. This is a GoLedger CC Tools chain code, but we will not use the crude methods, the create, use, create, read, update, delete methods that comes embedded with GoLedger CC Tools. So here I just commented all of them, so they will not be available. So for every transformation, every modification that's necessary for these assets, we'll have to use the methods I have shown to you right now. Okay, now let's deploy the Hyperledger Fabric network. I'll be using Go Fabric as an orchestrator for us to make this network and this blockchain to work. And I have already configured the organizations that will be available for the blockchain to provide, to transact. The first one is the ID department. It's gonna be deployed on this VM right here. It will not have an order, just appear. And we will also have two banks, Bank 1, that will have an order and appear, of course, and the Bank 2 that will have an order and appear. That's how this blockchain is orchestrated. And let's create the channel. I'll call it token channel. And I want all of 3 organizations within this channel. Okay, and now let's define the Go token chain code. Oh, it's not here. I forgot to upload the chain code to Go Fabric. I'm doing this right now with this script. And okay, so let me just come back fast. And okay, it's there, and it's here. Go token. This is the chain code I want. It's going to use a template. The schema of the assets will be registered in this template right here. That's basically a copy of the one that I have shown to you within the code. So it's basically the token with the TX ID, the owner, the quantity, the spent tokens, and so on, and also the wallets that have the ID and the public key, and that's it. So let's go back there, and okay, I will select the token UTXO. I will provide some credentials, some permissions. For an example, the token will only be available to be written or updated by Bank 1 or Bank 2, and the wallets will be only be able to be modified or created by the ID department. And okay, so all of them will have APIs, and the web interface that we use for development, and that's it. That starts this deployment. Takes us a few minutes. Whenever it stops, it finish, we will come back. The installing and the instantiation of the chaincode has just reached to an end. Okay, it's everything configured right now. So let's see the channel. Basically, I can see the token channel with this chaincode right here that basically has this tree organization. So let's go to the ID department organization using the web application that we use, Hyperledger use to deploy and test our chaincodes. And basically, we already have the wallet, we already have the token. It's already deployed. And let's go to the new wallet method. And as I said, we will create Marcos. Now we need to provide a public key in order to this method to work. We will use the OpenSSL command to create a new key pair. Let's say, and without Marcos.key. Okay. And the other wallet, that's called it's Rafael. Now we need to extract the public key from each key pair. So let's go with out. Okay. The method needs to receive as in base 64. Okay, let's remove the new lines. All right, okay, and that's it. That's the information I need. Let's copy it. Okay, and then we create, okay, the new wallet. Let's do the same for Rafael. Okay, so basically we will change the key pair here. All right, this is the public key of Rafael's wallet. All right, so I will create here. Perfect. Now let's issue another, the first token, let's say it's for Marcos, and okay, let's say 1,000 tokens for Marcos. Oh, I see what's happened. As I told you, only the banks can mint tokens in this blockchain architecture that I created right here. So let's go to the bank number 1 and then ask for a minting of a new token. This one is going to be for Marcos. Okay, and let's go after this minting. Let's go to the bank number 2 and mint some tokens for Rafael. Okay, using the issue token formation. Let's say Marcos had 1,000 tokens. Rafael has only 50 tokens, and that's it. We can see right here after the minting, the tokens are already registered here. They have the quantity. They have that boolean that say it has not been spent, each one. And of course the wallet of each token that we do have right here. All right, so we can also call the balance method. For example, let's see, Marcos has 1,000 tokens and Rafael has 50, and that's it. Now let's transfer some tokens. So let me go to bank one and see, I want to, let's say I want to transfer 100 tokens from Marcos to Rafael, and we will use the transfer token method. As I can see, it needs to receive the origin wallet, the destination wallet, the quantity, and the signature. So basically I need to first of all sign the information I'd like to transfer. So basically I say I will transfer from Marcos to Rafael 100 token, and of course for signing I need to sign a message. So let's go to we did have a kind of a trick here. This is a method that just returns the message that needs to be signed in order for the other transaction to work. So basically I'm saying it's pretty much simple, as I told you, it's basically this information here. So let's sign all this. So this message, so we're going to need, okay, that's perfect. All right, this is it. To open SSL, just message plus, okay. Marcos is perfect. Oh, this needs to be. That's it. That's the signing of the message that I need to provide to the transfer method. Okay, so let's go there and sign right here, and that's it. Basically, after this, all the verifications, we can see. Let's check the token assets and see what happened right here. So basically we burned the 1,000 token asset that Marcos had, created a 900 token asset token here, and created another 100 token, but this token has been transferred to Rafael. So, and as I said, for didactical proposals, we can see the asset that had been burned in order to this new asset to be created, and that's it. So let's repeat these transactions. Let's repeat it 2 more times. We'll say I want to go Rafael 100. Let's make a little mistake. Let's say I want to transfer 101, but we will see that the method needed a signed message for exactly the amount that was supposed to be a transaction. So basically we need to go with all the information, Marcos, Rafael, and 100 right here. Okay. Make this transaction one more time. Okay, so 100 and the signature, and okay, let's see how are my tokens right here. We have 3 tokens that had been transferred to Rafael. So this one basically has been transferred from the 1,000 token, this other one from the 800 token, and this one right here from the 900 token. So we are burning tokens and creating new one in the process of a UTXO schema in order to this blockchain to work. Let's check the balance of each token. For an example, here I can see Marcos has 700 and Rafael, that had 50, now has 350. And so let's make a last transaction. Let's say Rafael wants to return to Marcos some tokens, and say he's going to return from Rafael to Marcos, let's say 320, and we do need to sign. Okay, let's sign again. So this time it's going to be from Rafael to Marcos, and the quantity is 320. Okay, and of course Rafael needs to sign it. Okay, and that's it. So I need to copy the signature. All right, and that's it. Oh, I'm sorry, it's Marcos, Rafael to Marcos, 300, and the signature. All right, so now let's check how the tokens are deployed. We can see that we do have this new token of 30 that had not been spent, and we also had burned all the other 3 tokens from that had 100 tokens from Rafael. These tokens has been burned. This one also has been burned, and this other token has been burned. And if we can check that now Marcos do have a new token of 320 that had not been burned. We can see here which tokens let's say the UTXOs has been burned in order to this new token be created. So it had used all these 3 tokens and also created the transaction auto creation, the other token, with only 30 for Rafael. So if we do check the balances right now, so let's see the balances for Marcos. Marcos now do have 1020, and Rafael do have 30. Okay, that's it for today. We are planning to create some exercises and demonstration to show some atom swaps between tokens, from a token from Hyperledger Fabric, another ERC20 token on Ethereum. But in the future, probably we will release some videos about this kind of operation. I hope you like it, and for those who like it, please consider subscribe.